Good afternoon. My name is Fernando M. Gomez, and this is going to be a short introduction video on a small paper or presentation regarding the irrationality of numbers. Now, there are two irrational concepts or mathematical constants that we're currently, that my project consisted of, and it was a big focus on the constant mathematical letter pi and e. Now, these two mathematical constants are a bit difficult to prove, but there is a way to prove how they are irrational. And as we will see moving ahead in the presentation introduction, we'll see that they're actually provable by contradicting them. So let's get right into it. As we can see in the presentation, the purpose of this project is to explore the rationality of these two constants, pi and e. And again, it's to demonstrate why these constants cannot be expressed as fractions. Fractions, or numbers that can be expressed as fractions, are dubbed rational numbers. And in the case of these two constants, they're irrational, so they cannot be. And not only will it describe why they're irrational, but it will also highlight the importance of mathematical analysis through proof and deeper concepts like continued fractions and series expansions. So a little on the background of this information is that these two constants answer the following questions, which is, what is an irrational number and how can we use its definition? The definition of an irrational number is that it cannot be expressed as a fraction, such as p over q, where p and q are integers and q cannot equal to 0. And the reason is because when a number is divided by 0, it is impossible, it is undefined, such that when a number is not divisible by any other number, then it is not a fraction. Now, in order to use this definition, which is a very valuable information, we can use it to prove that pi is irrational. How? Well, this technique of proof is called contradiction. And contradiction is pretty much establishing the opposite of the result. So rather than saying that pi is irrational, we can say that pi could be rational, assuming that it is an original assumption without a conclusion. As mentioned previously, we can prove the rationality of pi through contradiction, or the opposite. In this case, we can assume that pi is rational. And therefore, proving its contradiction will prove that it's true that pi is irrational. So we can begin, just the introduction. We begin by assuming that pi is rational, and we write that pi is equal to p over q, with, or for some, integers p and q. And we can construct the following functions. E to the negative x squared times a plus b times x to the n. And here a and b are also constants. And n is a positive integer. Our a and our b can be values pq plus 1 and negative p over q. And the function is designed to vanish at a certain point. Again, because this is only a brief introduction, it is important to note that proving pi as irrational is going to be proven by assuming that it is rational, but at some point, at this certain point where it will vanish, it will prove contradictory, which in turn will prove pi to be irrational. This is only a brief example and a very brief introduction, but moving forwards, it will be presented how and the results, which should be a certain point that is vanishing, therefore proving that pi is irrational.